very quickly show that I really tried anything just to get this circuit done and working. And I have some old projects that I'm having here. I will not show them because they are old and really they are a mess. This is with op-amps. Here are also another op-amp here, and here another op-amp, and I believe, yeah, two op-amps here and down here as well. So the problem I had with this simpler one that is having these two transistors and only one logic gate, this XOR logic gate, but the muscle of the circuit are these two transistors pretty much. They are auto oscillating. It is my best guess. They are performing an auto oscillation when the probe is set on floating here. If you really want, you can build one probe like that with only two LEDs, extremely simplistic, with only two LEDs and probably two wires, one wire to the ground and the other one to the positive, and check only the highest. So there are some circuits very simplistic only for this kind of simplicity. I want to show you what I tried already. This is what I find on internet. This kind of circuits with op-amps. This circuit is for a logic probe 5 to 5K. This is 500K. So the next one, this is 5 to 5. So this 5 to 5, this is its circuit, internal circuit inside. This is 535. This is 535 here, and this is its circuit inside it. And as you can see, both of them, they are using op-amps. You see, this 70HC40. No, this is a logic gate. This is not logic gate. This is not using op-amps, but the other one, this one is using op-amps. This one I actually tried in Proteus and it worked. In Proteus, I didn't try this one at all. But as you can see, they are quite complicated, and I don't like it. And the floating mode was the important thing. Here in Proteus, it worked with the floating. As you can see, these two LEDs are staying off, and this guy for the floating is staying on. Perfectly fine, perfectly working, everything. If I'm switching now, if I'm going here to manual mode, the zero logic is open, and when I'm changing it to logic one is changing that one. And every time I'm clicking this guy, these two LEDs are doing the job. When I'm switching to automatic, you can see them flickering there. So everything is fine and dandy here in the Proteus simulator. And I was assuming in reality it will be as well fine and dandy, and it wasn't. It wasn't by a long shot. So in reality, I put 5 exactly like here. I put instead of that Zener diode, you see here the Zener diode, I put 5 diodes. Actually, this idea wasn't mine; was on a friend from England, my friend from England. On these 3 diodes here, pretty much to have this. This is a voltage drop. Pretty much, I'm dropping the voltage by a certain amount. Each diode is having 0.6 volts per diode. So, but my diodes that I'm having, they are not 0.6 like in the book. They are 0.3, and I have to add way more than what I'm having here. But I did exactly what my friend suggested to me, and I had it on the breadboard, and it still didn't work. The problem was with the floating LED here. When I was setting this probe to floating, all 3 LEDs were lighting up. When I was switching to 1 or to 0, to 5 volts or to ground, pretty much, the 2 LEDs were working correctly, and this floating LED was lighting off. So everything was correct only in this side. But when I was switching to floating, this guy, everything was showing on, was lighting on, and that was an erroneous behavior. And I had it for a couple of days. I stayed and I tried. I changed every resistors, every values 1,000 times, and I changed the transistor, the PNP. I said maybe the PNP is not good. Even the NPN that I have here. Well, what I wanted to show you here is that I tried a ton of stuff. In all this time that I'm, here is an overview of all the images that I just showed you. Here I made a grid. When the probe, I put it to positive or to negative or as floating. LED 1, LED 0, or logic 1, logic 0, and logic floating or LED floating. So when the probe is left floating, the probe is left floating, all these 3 LEDs were lighting on. Before, you see this is a corrected image. Here I had a line, meaning that it was off, and only LED 1 was on. For certain transistors, the PNPs, certain PNPs that I had, it worked, like that. But then I realized maybe this part is supposed to lit up both of LEDs because it's oscillating. It's supposed to have both of those LEDs on. So this one that I originally had with off, it shouldn't be. It shouldn't have be. So this for certain transistors, for the large majority of the transistors that I used, it was exactly this configuration that I'm having here. Special ones, 1 or 2, I had with off and only LED 1 on. So that's my little grid that I made here. It's good to show. Of course, it is a ton of discussions about the subject. We thought it's working from the beginning, from the start. I didn't think it will not work at all. It catch me with a surprise, not working in reality. Here in the simulator, I put a potentiometer here and here. In reality, I put 3.3 kilo instead of this 100K there. Here, and it is working absolutely fine. If I'm changing this to greater, you see that LED is starting to show some erroneous behavior. It's working here in the simulator on the floating point, and it is working in reality as well with 3.3 kilo. And I'm very extremely happy. Right, it's working. It's fucking working. And I changed a lot of values actually right now, very quickly, just to see if it's working. I had here a ton of diodes, a ton of them. 5 for the logic 1 and 3 for the logic 0. This is logic 1, this is logic 0, and this is floating. And now, and also I had these two LEDs, which are crappier and very old, and they don't work with 10 kilo, so they had 1 kilo here. And I replaced them with these super bright ones. They have a very high value of resistor there, 10 kilo per LED. To dim them quite much down. In the camera, it's looking super bright. They are even brighter than this, way more brighter. When I put 1 kilo, it's yeah, they're very cool. And on 0, so now I'm probing 0 and 1, and it's changing accordingly, absolutely brilliantly, absolutely fucking brilliantly. Yeah, this was the original circuit, that it didn't work with what I had there. So my friend from England figured out, of course, it was an entire discussion about this subject, and I tried a ton of permutation. He put me to try some stuff, and I tried by myself a lot of stuff, and I was showing him. I was building a context pretty much, and from this context, finally he deduced that is a leakage of the transistors. I was highly suspecting this PNP, but I changed it with, I have a ton of PNPs here. Usually I use this, the large majority that I'm having here, including these guys here, on which I have, originally I have them. Let's see, yes, I was looking for this marking. You see, emitter, base, and collector. Come on, there. So it's, I did mark them by myself with a marker. I actually write on them, and yeah, I used this, that one, and they behaved a little bit different, but very tiny bit. For the majority of these guys, the large majority, all 3 LEDs were staying open all the time. Before including these resistors. So I put 3 kilo here on their bases, pretty much by inserting this parallel 10 kilo resistors, and I will put only one single 3 kilo resistor there. If it's too low, it's not working correctly. If it's too high, also it's not working correctly. So it's somewhere, it's a balance between I kind of brutal tried everything here, but it worked like this pretty good. It's a bit flimsy if I'm doing this. You see, if I'm, yeah, it's sometimes it's staying lit, it's remaining lit one, but most probably is a connection somewhere. These are flimsy, very flimsy legs of the resistors, very thin. Yes, the transistors. So I tested with those transistors initially. I believe this is the PNP here. This is the PNP, and that is the NPN. So this is the PNP, and that is the NPN on the top. And yeah, in the simulator, I tried with only one resistor, but if I'm putting only one resistor instead of these two, only one, both these bases are kissing each other, and it's not good. It's not good. It didn't work. It did show me some signs in the simulator that it will not work. These two resistors are pretty essential. So one resistor per base, pretty much, you know. And yeah, it's fucking working, and I'm so happy. Thank you, England. Thank you, England. It's working. So yeah, my friend from England had a breakthrough, and he realized it's some sort of leakage. And these resistors from the bases of the connecting pretty much the base emitter in this case for the NPN, and base emitter for the PNP, like that, from the positive to the base and from the base to negative. Are this 3 kilo that I'm 3.3 kilo that I'm having there. I have to tweak it probably more than this, but it's working. It's okay. Making exception of the trembling that I'm having here. Sometimes I was getting only one lit up, but most probably it was something that took out from its place. And yeah, I'm very happy and satisfied. I kind of simplified it. And it's greatly simplified from the original circuit, and it's yeah, I really like it. Although I have a ton of resistors there, it's not that simplified, but it's good. It's very good. It's working. That's what I'm very happy. Thank you very much. Oh, it made me very happy, because I was trying on this circuit. I tried to make it work for more than 1 week. I had the other one with the op amps before this one, and this one came along, and I refocused. I switched all my concentration on this one from that. From the other one with the op amps that was full. It was way too complex, and in my mind, I told myself it should be a little bit more simple than that complexity that it was before with the op amps. But and I was right. I was perfectly right, and I believed in this kind of simplicity. I believe in transistors. I believe in the power of the transistors. So pretty much what I was discussing, what I realized by myself, and probably my friend, it helped him indirectly. This realization that I made. This side here, where I'm putting my finger, with the 2 transistors connected to the power rails there, of course their bases are connected to each other pretty much, and when the probe tip is floating, they are oscillating. They are entering in an oscillation. So this is an oscillator, pretty much. This is what my realization, what I realized how this circuit is doing. And this gate that is here is only when it's seeing different values on its inputs, is lighting up. So if it's one is positive, one is negative, is lighting up the LED. When both of them are the same, doesn't matter if it's zero, is negative or positive, but both the same, the LED stays off. That's it. It's a command chip. It's commanding. It's pretty much a logic chip that is commanding only that LED. And here it worked without these resistors before, but only for these 2 LEDs. It was switching from positive to negative, like it's switching right now. But the floating LED, the red LED that I'm having here, the floating LED, was staying on all the time. So these resistors helped calibrate the entire circuit for these 2 guys to stay off when it's floating, while before they were staying on all three together. And this leakage, I have to discuss with my friend exactly what he thought about it and how he thought about it. For him, I believe it worked with higher value that I'm having here. I believe he put 10 kilo, I think. And yeah, absolutely brilliant. It's good to have friends. It doesn't matter where in the world. It's good to have friends, and I'm very happy to have friends, smart ones, because stupid ones is full. The world is full of stupid friends, but smart friends is rare. So I value my friends. I have a few friends. I can number them on my fingers, but they are all very smart and very, yeah. Good job, England. If I'm not mistaken, no. I find another circuit, the third circuit, with only with the NAND gates. It was made only from NAND gates. This is it for this part. Thank you very much, and I hope I can create a much more smaller version of this thing that I have here. One last thing is that I spent a ton of time building. I made a lot of versions in my simulator. It worked in the simulator, but in reality it didn't work. And I started to distrust the simulator because it was giving me false positives pretty much. And I stayed, like I said, more than 1 week, probably 2 weeks, 1 week and a half for this entire project to figure out how to make it as simple as possible. And yeah, I will come with updates on this thing, and yeah, I'm very, very happy. Oh, wow. A lot of time I spent on this. I was thinking all the time, in the morning, in the evening, in the night, when I was getting to sleep, when I was coming out of sleep, I was thinking on this project, how to fucking make it working. I was desperate at some points, and yeah, I was trying to believe I will never make it work until my friend came with this, idea. Actually, I told him, try to make it on your breadboard there and see what's happening. And he did it. He listened to my advice. He built it, and he figured it out. But of course, he worked on a lot of experimentation that I did already, and with a lot of thinking, a lot of context. So good for him. What it matters is that it's working, and good job to everybody, including me. Oh shit, it was so hard. It was very, 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 very hard. The first test that I did, so pretty much I tested with the original circuit that I had it. So this circuit, what it really needs, so it needs from here a resistor like that. In my case, 3 kilo. But you have to experiment. So from base, so this is base and emitter, and this is emitter, and this is base. And from this point, you drag a wire and you put the resistor here. Sorry, my drawing. Also 3 kilo as well. It worked like that. And this solved the entire problem. This is the original circuit, and this is the only the solution for it. And now, next step, after trying with all these diodes and everything, and I said to myself, if I will simplify it, if I will put one thing, if I will remove all those diodes. So pretty much I took out all these diodes like that, and I connected this point to that, and this point to this base of the other transistor. Pretty much this is the circuit that I'm having right here. So let me undo. So this is what I'm having here without those diodes here. This will work. That was the question. If it will work like this, and I believe I made a test. This is the actual test that I made here in the simulator. Originally, I tried it in reality, and it worked with this 3.3 kilo per emitter base of each transistor. And after I've seen that, then I changed it here in the simulator, and I made it work with this potentiometer, which is very, very dubious how it's working. But the point is that it's working here in the simulator as well. As dubious as it's looking with these potentiometers at this very weird values that they are having there, but it's fine. It's working absolutely okay. And yeah, that's the point that I removed. And I simplified by removing those diodes from the top. I simplified greatly the circuit a little bit more than it was originally. Than it was here, that it was in original form, or the original idea that. Thank you very much for watching, and see you later from the best artist, Mr. Q12. Bye bye.